Batman drives off a cliff in his Batcycle. What must his velocity be when he flies off the cliff in order for him to land on the Batmobile, which begins exiting the Batcave at the exact same time, 200,000 meters below him, with an acceleration of 1,000 meters per second squared? Okay, so here we have Batman. And Batman, of course, has his bat symbol, his bat cape, his utility belt, and of course the bat chin. Next we have the Batcycle, with its bat jet engines or whatever. And then we have the Batmobile. That's pretty awesome right there. Okay, so let's say Batman is on top of a cliff that is on top of the Batcave. And the Batmobile is at the very bottom. As soon as Batman reaches the edge of the cliff, he's going to try to fall off and land on top of the Batmobile. The height of the cliff is 200,000 meters high.
Warning, drawing not to scale.
The acceleration of the Batmobile is 100,000 million. The acceleration of the Batmobile is 1,000 meters per second squared. Dudes, in this business, we do stuff. Some numbers, a little bit of magic, Harry Potter.
Right. So first we found how long it takes Batman to fall using the second kinematic equation, which comes out to 202.0305089 seconds. Then we use that in the first kinematic equation to find out the final velocity of the Batmobile, 202,030.5089 meters per second. So we know that the acceleration of the Batmobile is 1,000 meters per second squared. Its initial velocity is 0 because it's starting from a complete stop, and its final velocity when it meets the Batcycle is 202,030.5089 meters per second, which we just found. We put those values into the third kinematic equation. Final velocity squared equals the initial velocity squared plus twice the acceleration times x final minus x initial. Since the final x position minus the initial position is the same as delta x, we substitute that in for xf minus x naught, then move the 2 times 1,000 over and solve for delta x, which equals 20,408,163.26 meters. So now that we know the delta x and the total time, we can use the equation delta x equals initial velocity times time to find out the initial x velocity of the Batcycle as it flies off the cliff. We put the information in, solve for initial x velocity, and get 101,015.2544 meters per second.
The velocity at which Batman has to leave the cliff is 101,015.2544 meters per second. This may not seem possible, but we're dealing with Batman here. So it's possible. Not taking into account air resistance or curvature of the Earth. Squeeze. Na 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 na. Batland. All right. That was good.